Welcome lecture 7, Big Data Ecosystem, including tools, processing, and the other section like analyzing. This part is very important part of our semester's lecture. We already started to discuss many parts regarding the artificial intelligence so far, and many sections and under section of the AI already covered during this semester. You may remember we already started to talk about the big data in previous section. But today I would like to very professionally discuss about the big data from practical point of view. Whatever I explain as a theoretical part, then we will go for some practical part. You may know about the big data already, we already discussed, and you already have some knowledge from another resource. But today I would like to really open new doors for you to understand what the concept behind the big data and what we can do really with the big data concept and how much big data is important. I am sure after this lecture 7, you will be very interested to the big data. What I believe, you can join to the company after finishing our lecture, which was part of our semester course, which was the AI, and this lecture we will focus about the big data. So you can join to many company which they are working on AI or big data. You know, most of the AI classes, even their name is the artificial intelligence and big data, they try to touch AI mostly, and they don't go for the big data. There is many reasons for that. One reason is that AI has many parts and very difficult to cover all parts during one semester. And then there is no time to go for big data. This is one reason. Another reason, because big data, really big data concept and implementation and programming is very complicated. And many experts who they are working in the AI, they are not familiar with the real deployment of the big data. But the good news for this semester, I try to arrange times and schedule, come to the point, bring to the some step, which finds some time and great scheduling to reach to the big data. So today is that day. Okay, let's dive into lecture 7, specifically go through the any concept related big data. So let's start with our agenda, which is very important. Before you go inside the lecture, you need to understand what I'm going to cover. As you remember, during a previous lecture, somehow I started to talk some concept and very important concept of the introduction to big data. And we discussed very nice, concept, and that was very important for AI as well as for, a combination of the AI. So we already discussed enough. Even though those discussion, it was enough for one semester. And even if I don't teach today lecture, that teaching was enough and good enough for understanding of the, big data concept. Today again, I will, do some summary for what I already told during several, lecture video before. And then I will go through very new concept related big data. What I explained today is very, very different from what I already explained before. Before was basic, it was introductory, and it was, mostly pure theoretical concept. But what I already decided to teach today, although you will see some theoretical, but behind is some practical concept, and that would be very important for learning and working big data in industry. So I will touch very important section related big data. So I will start with the big data ecosystem. Big data ecosystem, simply it is including three important parts. So some big data, I am talking practical point of view. You think about that the way I am teaching, after that you can work for some company. You can apply for some project. So from that point of view, big data ecosystem, including one big data storage, another is a big data processing, third one is the big data analyzing. To run these three sections, there is one preliminary and prerequisite section, or pre-data preparation section, that is data ingestion and ETL process. This step needed for these three steps. So all together under big data ecosystem. So I'm going to explain very professionally. Remember, you should understand my purpose is just, a practical point. To learn something, to do some big data analyzing. To do so, we will touch some concept like, big data storage, traditional storage type. What would be difference between these two? To, reach my goal, that means ability to join to some big data company, I add very important section and concept. Basically, if you want to watch a YouTube, you cannot find from the way I am explaining. Of course, you may find some, section, maybe explain better. Maybe you can find some better material for some specific section, but you cannot find whole big data plan. This whole scheduling to teach what is based on several years experience. So you should spend a lot of time in the YouTube to find what I'm going to explain. Simply to the point. So please be careful and watch this video several times. So we will touch some tools, big data tools like Hadoop, evolution, MapReduce evolution, Spark evolution. We will go for some concept like RDD, resilient distributed database, because big data is not going to be one place, many places distributed. So we will learn about some abstraction. Also, we will see some abstraction DAG. So we will talk later. These two is very important for Spark. Practically, not pure theoretically. Practically, the RDD and DIG is very important, which is called DAG. Spark architecture, frankly speaking, is very complicated. If you want to study by yourself, read a book, or watch many material, even online courses, you should pass many courses to understand, practically. If you want to join to some company, you should have some great experience working in a real project. You should familiar with very basic and very fundamental concept of the Spark. And if you have experience participate in the interview, many questions they may ask you. The way I'm teaching you that in that way. So very conceptually, which if you follow my lecture very well, so you will reach to that point. If somebody do not have a pure understanding of the big data, it is very difficult for that person to teach big data. And then if any student, they don't go, deep concept, which I tried during this semester, you cannot find any material like what I provided during this semester for AI part. For big data, same. Especially big data, many teachers, they don't touch because it's complicated. They need many times to teach simple thing. But I will teach you very easily, in very easy way, and very interesting way I try to use in my lecture. So this Spark architecture is really complicated, but I will teach you. You remember Einstein said, if you cannot teach to the 12 years old boy or kids, you cannot, claim that you already knows that concept. So don't worry. Do not, worry if your major is not the CS, because the way I'm teaching would be very easy. Maybe you ask why I am spending too much time in agenda, because I want to make everything clear and then make your mind ready to reach to the very nice section. So we will talk about the Spark SQL, this very important part, and as well as concept of the NoSQL DB MS. After touching this part, then we will go second part of the big data ecosystem, which is big data processing. So we will talk and explain. Maybe some of you said, okay, processing and analyzing is the same or similar. No. So we will discuss what are the difference between these two. In here, also we will discuss, how big data can combine with the AI. Very interesting part, because our class is the AI and big data. Then in that classes, here we will talk about the big data analyzing, including many, big data analyzing, including 4 parts. It is EDA, big data EDA, exploratory data analyzing, and then big data for predictions, and then statistical, and then big data visualization, which these 2 parts, which is very important, then we will discuss. And finally, at the end of the lecture, we will touch big data security, privacy, and some big data application and future trend. Big data ecosystem. So we will touch several sections and focusing to ecosystem. When we talk about the ecosystem, we will see many sections, which I'm going to explain now. So this introduction is a basic, but detailed discussion today is a summary of a big data. But detailed discussion and explanation, you can refer to previous video, which I already discussed a lot. But today, just recap what I already told at that video. So we will not too much stick to this section. So we already start definition of the big data and talk about the characteristic of big data. Many models we already discussed. Please pause the video and tell me what is the big data model we already discussed. Okay. In that big data, many V's start from 3 V's, 4, 5, 6, something like that, 9. So we discuss a lot. So please review those parts. And we discuss about the traditional data processing to the modern and big data architecture, use cases, and many other things. Remember, we talk about the data-driven intelligence service, data-driven AI, data-driven decision-making system. So data-driven is very important. So then data can play as a new currency. And the interesting things, 90% of existed data in the world created within 2 years. Wow, how fast? Within 2 years, 90%. So 80% means many enterprise, many companies' data is unstructured. And it is not structured data, because structured data is old database is based on the structured data. Many DBs like Oracle, like SQL Server, those is the structured data. But when you come to unstructured data, video mixed together with the text, with the voice, with the table, those are growing double these days. And 80% is unstructured. So then data would be a new currency. So value extraction, it is very important for how you are expert in the big data, and AI is challenging. So now we are in the age of big data, lots of data. So we have some sort of explosion. Why? Because we don't have much time to store data. So many big data platform, like Hadoop, making storage 10-20 times cheaper. And many big data processing, even like Hadoop family, like MapReduce, we will talk. New big data processing like Spark coming 100 times faster. So many, DBs, NoSQL DBs coming like MongoDB with a more innovation and growing user community. Please refer to previous slide. In the previous lecture, we discussed what the big data is, history of that one trends, and talk about why big data is important. So you can refer those lectures and then come back here, continue watching this lecture. For who doesn't have much time, I just put a simple review of those lectures. So we discuss a lot and talk about big data. Start from many V's. Data is many. Speed of data is high, and type of data, many type of data, which is not same type. So this is a start. Douglas as a 3V, and then IBM introduced one more V, and then 6V, coming to 5V, and several V we already discussed. Please return to those sections and review it. That would be good also, not only for this lecture, but also for the final exam. I summarize those V, that table, I bring it here because that would be useful. Within short time we can touch those concepts. So 3V talk about the volume, velocity, variety. How data fastly flow. So this is velocity. And then we bring a veracity. How much we can trust to the accuracy of data. And then one more, we added by them Chenoko, that extracting value for actionable inside of data. Then Microsoft add one more, feasibility, ensuring data easily visualized Because when you visualize, you can get many insights. And Microsoft introduced Power BI, Power Business Intelligence, as a tools to help you properly, present big data. And then come to more extended big data, like validity. Really, you can, whatever data set, when you go to the reality and to that area, that accuracy and your data same. For instance, you are talking about some building, height, building, type of material, interior design, some information. When you go to the near to that building, should be data right. So this is the we call it validation. Validation means your data in computer, it would be same in the real world. So then many others, like should not be vagueness, should be, especially this part for a sustainable development is very important. Why? Why we consider many characteristics of big data? Because we are going to do data-driven decision making. So that's why it is important. Okay, let's go next page. Just as an example, when we talk about the 3V, each V has a tools. Tools handling volume, tools handling velocity, tools handling variety. So we will today touch some of them. For instance, here tools for handling volume. So many, a smaller data set, usually around the maximum 10 giga, like Excel, Access, SQL. But we are talking about the large scale storage and not concentrated in one place. Sometimes your data is this centralized data. You sometimes said, I have a big data, more than 10 giga, around a terabyte. But sometimes you said, I have a big data, but it's not one place. Distributed, one data is here, one data is here, one data there. So this is Hadoop can manage those distributed, data. So now for the variety, many sort of data. So you have unstructured data, like video, satellite image, Facebook data. Velocity, speed is important, real-time data, traffic data, CCTV data, many data. Then many tools, we are talking about tools, like Kafka, all is the Apache, Storm, especially Spark, wonderful. So in our lecture, we will touch a lot Spark, wonderful, environment and platform. So challenges of big data, as I told you, data volume, data velocity, so data variety. So those is a big challenge. Scalability. So, we want to do keep data not in one places, sometimes because of security, sometimes because of cost management. Some data, for example, retail company gathering data from different countries. So data scaling is not small, it's big scale, distributed. So then you need to manage those processing. You need to scale up hardware. You need to scale up software. So that would be using the distributed system. And data quality, accuracy is very important. Many people, you have a data two different places. But this should be synchronized and not duplicated. Should not be data redundancy. Data redundancy means repeated one data 2 times, because database is 2 places. You are in Seoul. You connected to this data, for example, Kakao company doing, you access, you are in Korea. Then you travel by airplane, go to the, for example, USA. It's very difficult from USA you connect to this server because of many reasons. You should connect the server there. But you already talk some part, do some analyzing your personal data in Kakao company. You did when you were in Seoul. When you are here for 2 weeks, you did some change. Again, you back to Korea. My airplane is not good. So airplane again come to Korea. Then when you back here, some portion of data here, some portion of here, how mixed together, how can find duplicated? This is the challenge in a big data processing. And cost and infrastructure is very difficult. You know, computational resource costly. So this is the issue you should consider. Now, let's talk about the big data ecosystem. So there are several big data technology which we need to know. Not just saying, okay, big data means big data, means data is big. But when you don't go in detail, that is the issue. So we will go in detail, but in a very easy way. Component of the big data ecosystem. 3 main components of when we are talking about the ecosystem. Here we mean processing, storage, and analyzing. There is a one part which is preliminary steps for storage, processing, and analyzing. That is called data ingestion and ETL process. ETL here means extract, transform, and load. We need to extract, transform, load, process before we go doing the storing data, big data processing, big data analyzing. So, and also when we talk about the ingestion, you know, ingestion, when we take the food, you know, take some drink to, you know, any substances into our body by swallowing and by absorbing it. This is ingestion. So when we talk about like that, is like, you know, eating like food. This process and extract and transform and load to the system in all of these two, in all of 3 main category exist. So then here, storage same, and processing here, and analyzing here. But analyzing itself has a many subcategory. One is the exploratory EDA, data analyze. Means you try to explore what the data are, any correlation of data, any specific part of data, anything anomalies, or any specific sharp trends. We will define some hypotheses and try to reach to the some point. Or we will use some predictive model, like what we did during semester using machine learning, deep learning, or even data analyzing to predict. And finally, how visualize data. More professional visualizing is getting better for big data. And security is very important because data is distributed. Privacy. So in the big data ecosystem, Hadoop and Spark ecosystem is very important. So we will nicely touch in our lecture. So For big data technology, many aspects exist. We need to think about big data framework, platforms, tools, because we are going to massive of data structure. Normal tools, the tools you use like Excel-based SQL database, it is not works here. So these tools let many companies extract value from big amount of data, and not only big, but also not a static, is a stream data, like traffic data. Every time traffic is changing. It's not one time you collect, okay, number of students at Sejong University, put in the DB. For this year's, it's fixed. Maybe during semester, 100 students add, that's all. But in the traffic data, we have a huge data which is extremely, every second many data come and many data go, some data deleted, some data added. So this is totally different. So in big data ecosystem, as I explained, storage, processing, analyzing. Storage, like, you know, HDFS, this is file system, is a Hadoop distributed file system. So this is HDFS, Hadoop introduced by Yahoo. You may remember, we discussed before. And this DB is not normal DB, is a distributed and big data DB, is not SQL based DB, is a NoSQL, like MongoDB, Cassandra. You know, this is a mix of the structure, semi-structure, and structure. Processing actually, like Hadoop and Spark, you know, to process data using the batch and the real-time methodology. When we talk about the batch, means batch ingestion. Data is ingested as a scheduled interval in chunks and or batches. For example, loading daily transaction logs into a database. So data is coming by a chunk of data. Or real-time, streaming. Data is ingested continuously as it is generated, like traffic data. So this needs processing. Is Hadoop and Spark is good. And for analyze, we will touch some MLlib. Spark MLlib is very good tools for ML, means machine learning. Lib is library. That is a good example. So for big data, big data, as I told you, pre-processing, we need to do data ingestion, collect and streaming data from multiple resources using maybe API, weblogs, or IT devices, and using ETL process, extract, transform, load data. And so we will talk about the HDFS. HDFS is a Hadoop distributed, means you split data, means you divided data to several blocks and put in different places. And talk more about the NoSQL DB, many type of NoSQL DB we have. Example, like MongoDB is the document stories. Redis or Cassandra is the column, and there is one more, so we will talk. So in this part, see more detail for big data processing. Actually, this is pre-processing and framework, like batch processing, like Apache Hadoop, or real-time processing, which Apache, Spark. Big data analyzing, we already talked. This is the example like Python Pandas, and for a statistical is R and Python SciSpy, and predictive modeling more machine learning AI-based Spark MLlib, and visualization like Matplotlib or Tabula. So for security and privacy, there is like GDPR and HIPAA, and this is the more using for also Apache as a ranger for security and privacy. So for processing, MapReduce, which Spark new version of MapReduce, we will talk more. Spark is the 100 times faster than this model. So for managing data clusters, Yarn is Hadoop family Yarn, and I will show you the Hadoop ecosystem. You will see mostly about that one. So in the Spark ecosystem, this is a Hadoop ecosystem. The advantage of Spark, which is in memory data processing, and when we doing coding, we will use the Spark SQL as a query through the big data, and MLlib doing machine learning in the big data. And this is a framework for graph processing. I would like to here refer you to our topic, which was program enrich DIKW. You may remember this prompt. So this prompt, I want to connect to big data as well. Big data, ecosystem. So to connect to the big data ecosystem, the big data storage in this part. Processing, either batch processing or either real-time processing, is going to this part. And extracting the insight and more doing some data-driven decision-making, more advanced algorithm. This is big data analyzing. Wow, very nice match between the big data ecosystem and the IKW model. I can talk a lot, but we don't have much time. Let's go other part. So big data, data ingestion. We talk a little bit generally about that one. Now I'm going to a little bit go in detail for data ingestion and ETL process. So this data ingestion and ETL, this is very critical, section for other three: the storage, processing, as well as analyzing. So, but for analyzing using extraction of the data, but in the processing and storage is still in the data level, is very close to the data level. So that would be is very important for that one, and less important for the data analyzing. So the word meaning means taking food. So ingestion, we need is a step. We give the food for these three steps. So when we are talking about the data ingestion, means we are talking about the process, means accumulating, the important and significant part of various, data storage and processing. So data ingestion is the entry section of eating the data. So very important point of how we control inputting data. So data ingestion, including two parts, batch ingestion and real time. In the batch ingestion means data is like block based on some schedule, enter to big data system. So this is the big data. But in the streaming data is like river, stream data. Data is coming. So these data can be similar like many sort of database API likes stream data files. So tools for data ingestion for batch part is like Apache Scoop or Tale, and real time like Flume or Amazon Web Service. So this is the very important point for data ingestion. So when we talk about the ETL, means the process extracting data from several resources, because it's a big data, and transferring to the proper format, load to our main ecosystem. You may remember storage, processing, analyzing. So when we talk about the ETL, means extract, means retrieve data from various sources. And then transform means we need to standardize, or we need to fix data, clean data for our three main important sections, and then load it to the processing system. So ETL or ELT, there is a difference between ETL and ELT. In the traditional ETL, both start from E, means extract data. But in ETL, first transform data and load it. But in the ELT, load and transform. This is means transform can be doing even during the analyzing. So load first, like data lake, is more complicated, ELT. And this is some sort of, this is based on the distributed, this is based on the data lake. So for ETL tools like Apache Glue, Apache NiFi, and AWS Glue. Okay. Why ingestion is important? Because we need some sort of bridge between the phases. So you need to feed raw data to system. So this is ingestion. We need transfer raw data into a structured format, ready for processing and analyzing later. So that's why this is important. So ETL makes data structured format. So this is pre-processing part of data preparation, rather doing computation or storage. So in the ETL and ingestion is a preparing. If I give you one example, data ingestion like collected user activity log file from web application using Kafka. And then, ETL processing using, extract means you pull log of the Kafka, transform it, and clean it and load it. But if we, this is an example for Kafka. If I explain another example for Spark, which is close to our class, then I could say, because our class, we will touch more about the Spark. In the ingestion part, we collect a user log file, a stream base, means data is coming from data source, like file system, databases, and API. Data is coming, distributed and unstructured data. And in ETL, what the Spark do? It will be extracted, read data from the source, and then clean it. Remove any outlier data using a Spark data frame API or Spark SQL. Then write, transfer data to the HDFS. Is a format, is a file system, Hadoop distributed. Is a just format. for distributed. So this is the both is the pre-processing, but ecosystem has the two other part. Storage, you need to store, Spark is not good for storing, so you need to use Hadoop. But for processing, Spark SQL is good, and analyzing like MLlib in a Spark, that would be very good. Okay, let's go another section, which is big data storage system. So we would like to see how big data storage system work. You remember, storage is the first part of the ecosystem. Before it was ingestion and ETL, but now big data storage is the first part of the big data ecosystem. So we want to storage many sort of data. We need to support security and scalability. So store data, whatever data, structure, non-structure, or semi-structure. So distributed data across multi-server. So we want to, manage distributedly. We can reliable that those data. Provide, redundancy to prevent data loss. So data should be make sure we do not do process when losing some data from a server. Okay. There is an important point which you need to understand. Just quickly remind you that traditional storage, what is the difference between traditional storage and big data storage? Traditional storage focusing mostly to structured data, but here is many sort of data. Here is centralized, standalone. Standalone means only one. Unix, centralized. But here, not centralized, distributed. Here is a vertical scaling, adding more resource to a single server. But scaling here is a horizontal, adding more server to cluster. The server is like this, is connected horizontally. But here in our office, we add one more, same in one place. In university, we add something. This is more traditional way. Data size is medium, small size, but here is a massive size. Flexibility. So this is a limited schema. Data limited, but here schema, unlimited. Schema less means unlimited. And tools is like Hadoop can use big data storage. So here it is very good table. Let me put here. This is a very nice table, including many big data storage within one table. We have type, this table including many type, right? We have many type, distributed file system, cloud-based storage, NoSQL, DB, data lakes, data warehouse, object storage, and hybrid storage system. So in the distributed system means system is split to the several pieces and distributed from different places. When we are talking about the cloud-based, means storage provided distributed but connected through the cloud. And NoSQL is a database optimized for unstructured data and semi-data, because normal DB usually is structured data. Data lake is not centralized. Is a big data. You know, all of them is big data. Remember, all of this is big data. But this is centralized. Data warehouse designed for structure and process data for analytics and reporting. Data is huge, but it's structured data. Consider data as an object. And it is good for unstructured data like image, video, because every piece of data is an object. Hybrid is a mix of distributed or cloud. So key feature is scalable and should ensure fault tolerance and reliability. This is important. For Hadoop is this family. You know, Hadoop is here. Like Google file system is here. So this one is the highest scalability. This is good. But for distributed system, complex setup. Maintenance is very difficult. Less people can understand this structure. So learning is complicated. But for cloud, this is fully merged and very well on demand and easy to access, like Google Cloud, Google Drive. But problem is money is very expensive. Everything, your data in cloud. For NoSQL, like MongoDB, Cassandra, Redis, or Node4j, handle semi-structured data through the centralized DB. It is good. But maybe consistency would be vanish. So this is a problem, and less people they are familiar with the NoSQL. Data opposite data lake is opposite of the distributed. Hadoop also has data lakes. Azure data lakes. Store diverse data type, cost effective for large scale store. But the problem of data lake, lack of data governance. So getting queries is complicated through this big data, centralized big data. So data warehouse example is BigQuery. So easy to use for structured data. So the problem, because this is only for structured data. When we go object-based, save data as an object, like cloud object storage. So when you go for object, like advantages of object-oriented programming, there is advantages. But because this is not good for structured data, and there is a higher latency for frequent access. So many times you want to access like Hadoop, it is not good. So for hybrid is a pros and cons together. For others, every advantages come to some software like Dell EMC hybrid. Flexibility is good because this taking advantages of each one, but very complicated to implement. Okay, this is the all DB structure, and in the other part I will put some more information. So for distributed, this is more information of distributed, splitted, scalability high. This is important for this semester for us, Hadoop distributed file system. Cloud is on demand. Google Cloud Storage. Like we already talked about this one. As I told you, one is missing. This was Graph DB. Key value, we will talk more about this NoSQL later. So data lakes is for structured data. This is the problem. But advantages is centralized. For some, for instance, sensitive data, you want more control. This data lake, it would be good. And data warehouse, we already talked that this is good, optimized way, like Google BigQuery is good, and Amazon Redshift, it is good for data warehousing. Here, bring the concept of the data as an object. So, for example, when we have a like Excel, you need to have a, for example, in the SQL, it is very difficult. You save your in the table as a video, but when you go for object-based, it would be easy. And the hybrid is a mix of all of this. Okay, let's summarize it. What we already discussed, that there are more than 3 big data storage, but 3 of them is simplicity, popularity, distributed, NoSQL DB, and cloud storage, and considered data lake is popular. Now let's little bit talk about some big data tools. This is very important, especially for that point of view. So we already talked about the storage, like Hadoop is a storage, remember? And MapReduce is good for processing. And Hive and Peak is for analyzing. So pros and cons. Storage is highly scalable. Scalability is high, but very complicated for setup, and require manual scaling, like we already explained. But this is the old distributed. I add some new distributed, like new than Hadoop for storage. This is like Google Cloud. This is cloud-based. So, but the problem is the money. In the relational database, this is old. New one is a NoSQL. You can read pros. This is a positive. This is negative. Positive, negative. So they are vice versa. MapReduce. Remember this practical part. We will go for Spark, because Spark is totally new compared to the MapReduce. And MapReduce is including 2 parts. Map and reduce means map different data when you want to map together, and if too many data, reduce to less dB. So from, for example, here 4, you reduce, map reduce. First map connected and then reduce it. So handle batch processing, it is good. Fault tolerant, it is good. But disk input output is slow. Complex to write custom code. Customization is very difficult. But in Spark is the new version of MapReduce. In terms of the speed, faster. Maybe Spark is 100 times is faster than MapReduce. Support batch streaming, so it is good. But the problem of the Spark is high memory needed. So if your project is small, it is complex to understand and run it. So for a small project, it is not good. So it is better not use Spark for big project. Why not? And here is a for processing ETL, traditional one. But Apache Beam for ETL, remember ETL, pre-processing. Then this is well tested, but not scalable. But the problem of most Apache is a new one. MapReduce, it is for Hadoop, but this is Spark for Apache. So this is good for real-time streaming, but it's very complicated. For analyzing means extracting the, insights. Hive is a Hadoop, is the old one. Pig is Hadoop, but the new one is the Power BI, which is for Microsoft software. Apache Drill is very good for analyzing, but Power BI you need to pay. So little bit limited for scalability. Okay. Let me explain what does it mean. Many times I am saying distributed. I want to show you meaning of distribution. When I am saying local means we have one computer. Distributed, we have too many computers. Sometimes in your computer you have a 4 core. But in distributed, core will be distributed. So this is the difference. So scalability is good. You can add machine. And also, if some machine failure, still system can run. So this is the advantage of distributed. So lower power machine efficiently you can use in distributed. You don't need buy many big computer. Yeah, this is the point of the. So let's go a little bit talk about the like Hadoop, and talk about little bit more about the MapReduce, and then go for Spark. This is a good timing to talk about those environment. Okay. About the Hadoop framework is various for framework for the big data ecosystem, and Hadoop is very complicated ecosystem has, and support for big data ecosystem. Hadoop is good, has software for big data storage, big data processing, big data analyzing. For example, for storage, Hadoop is good specifically for storage, because based on the HDFS, this comes from the Hadoop name when introduced by Yahoo. HDFS means a file system based on distributed file system. So this is a distributed file system, means you can divide the data into the block and distribute it through many DB. Ensure data, replicating block across the node. So even 3 copy can manage it. Support for large database and dataset. Compatibility with the semi-data and, unstructured data. So this is good for big data. So storage is very good, Hadoop. Processing is good, like MapReduce. So MapReduce is a Hadoop. So we are talking only Hadoop, not a Spark, only Hadoop. So the MapReduce is good for batch processing, can do based on the schedule based oriented we can do. Scalability good, and this durability is because this is the map reduce is a family of Hadoop and easily can store HDFS. So has a limitation, is very slow compared to the Spark, very slow, but has advantages, is a Hadoop family. So regarding the analyzing, Hadoop actually is not basically good for analyzing, but can integrate with the others. Hadoop like many features like Hive, Peak, we will show in the image in the 3 slide later. So store is good, Hadoop, but analyzing not much good. Processing good. This is very good for storage, remember. So Hadoop is good for storing and batch processing. Big data can real-time processing and doing some analyzing. Other tools like Spark integration within Hadoop ecosystem, that would be good. So this is the history of Hadoop from 2002, and then 2003 you can see Google released white paper about them. MapReduce developed the Hadoop, started some levels, and then come to like Hadoop 3, and they come to the even current more recent version. So we would like to see a key characteristic of Hadoop. One is the scalable, and another is the Hadoop characteristic is the fault tolerant and cost effective. And this is the core component of Hadoop, is the HDFS, MapReduce, and Yarn. So as I mentioned, scalable, fault tolerance, and this is the more. So I'm going to show you one more as a ecosystem. The next page is very important. Wow, it's very nice. Among the figures which I looking for, this is the best. Very clear and very informative. So here you see that Hadoop HDFS is a data storage beside Azure Blob or Google Cloud. So in our practice, we will use the Google Cloud and Spark hands-on exercise. So Hadoop MapReduce is a processing. Here is a storage, remember. Amazon S3 is a storage. So you need also cluster manager. You have your data, but is at different places. So means this is the cluster. And then inside each cluster, you need to do some task. So job or task inside the cluster. So this is the cluster management. Yarn is good for that one. For AI, we will touch to the MLlib, Spark MLlib, very hot machine learning, big data. Previously, we talked about the normal machine learning, but many algorithms, similar algorithms like random forest, decision trees, those SVM, all can be used for big data as well. So Spark is playing very nicely For data analyzing is a Hive. And Scoop, this is the ingestion. Kafka is the ingestion before we come to, analyzing. Here is the storage. This is the processing, storage, processing, and analyzing. So here is the before. This is the ecosystem, main ecosystem here. But ingestion is part of ecosystem. So this is the data. Very nice figure. Everything clear. MongoDB is here. Okay. Now let's talk about the concept of Hadoop, HDFS. When we say HDFS, how it works means in our node, it will be distributed node. Each node has a CPU, RAM. So then this is connected through the data node. So we will divided our block, and then scalability and easily HDFS used like master-slave architecture with the name node master, and this is slaves. And now let's see Hadoop in each section of ecosystem, big data ecosystem. So MapReduce, now Hadoop finished, now we are in MapReduce. So there is fewer slides, not much, just introducing MapReduce because this is not gonna be our main software. But you need to know, as I already mentioned, this is the for processing. So it is not for storage. Hadoop is for storage. So basically, good for processing, not storage. And this is good for parallel processing. It is including there is a two-step model I already explained to you. It is based on map first and reduce later. If I show you next page, like this, you have a many DB first, you map, and then reduce to 2. Fault tolerance, automatically handle nodes failure, so this is good. So one of the problem of the MapReduce is here. Spark, MapReduce is disk based, read and write on the disk. But Spark use them memory based. But here is not memory based. It's a read and write on the disk. Spark is based on the memory base. So as I told you, is not a storage, MapReduce. However, Tidely can use, because in the family of Hadoop, can use HDFS, which is Hadoop or Amazon tree mixed together to solve that problem. And okay, we are going to finish the first part soon after 2 slides. So MapReduce, for analyzing, it is not good for deploying other, extracting the insight and inferencing using AI, not directly. So, but by using some tools like Hive and Pig, or doing some customization like Python or other language, you can add analyzing to it. So sometimes this is complicated, but so that's why many people, instead of using the MapReduce for analyzing, they use, because analyze is very weak, the storage no, only for processing is good. So as a conclusion, MapReduce is for processing engine. and while it enable analyzing, it is not optimized for, it is not good for real time and advanced analytical. If you want, then you need to use Spark. So as I mentioned to you, it through the two steps, reduce and do first map and then reduce. Okay, one example I would like to show here how map reduce work. For example, you have like this word in your big data, like deer, beer, river, car, river. So you want to count, occurrences of each word in a large text file. Then at the first stage, map phase, because it was including map and reduce. Split text into word. So this text split to the word, splitting. And count each word's occurrence in each data block. So how many times? Here, 1, 2, 3. But each one is 1, 1, 1, 1. This is car 1. This is mapping. Mapping is many car 1. How many car? 3. Bring these 3 in one block. Deer is a 2. Bring here. River 2. Beer is 2. And then this is shuffling. Remember, splitting, mapping, shuffling. Shuffling means when you do mapping, you optimizing to reducing to the, for example, beer is you put one word 2 times. Then final result. This big data, this is processing. You don't extract insight. The meaning of process, you can understand. You just ready to do AI. It is ready to do machine learning. This processing on data you do to here, then you can apply AI or some analytics. Analytics needs some pre-processing. This is processing. You see? But this text by machine is very difficult to add the AI. But this process makes it is ready to use it. Okay? We already cover many issue related big data introductions, and then talk about the big data models. And we started big data ecosystem, which is pre-processing like data ingestion and ETL, and then storage, big data storage, big data processing, big data analyze. For that, we talk about the DIKW pyramid and talk about what is data ingestion and ETL process. After that, we come to some big data types, distributed, cloud-based, like NoSQL, data lake, data warehouse, object store, and then come to some tools for storage, like many Hadoop. New one is, we told that like Google Cloud. Relational is a storage, but new one is NoSQL. Processing map reduce is good, and new one is Spark. So for second part video, we will talk about the Spark specifically before we go hands-on practice for Spark. Thank you very much.